Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Examples of continuous distribution in testing of hypothesis. An important advice. We should be nice to everyone. This question is from March 21, paper 6-2, question 3. An architect wishes to investigate whether the buildings in a certain city are higher on average. So he is looking for an increase in mu. So he should perform the upper tail test, one tail test. Then buildings in other cities. He takes a large random sample of buildings from the city and finds the mean height of the buildings in the sample. He calculates the value of the test statistic z test, which is 2.41. Explain briefly whether he should use a one-tail test or a two-tail test. A one-tail test. Because look for an increase. Carry out the test at the 1% significance level. So we need to check what is the value of 1%, either from calculator or normal distribution table. So this value is 2.326. This is known as Z critical. If you are using calculators, put 1% directly. If you are using normal distribution table, then find phi inverse 0.99. And you need to compare these two values, this with this. You need to write as 2.41 lies in critical region. See, 2.41 is here because it's greater than 2.326. That is 2.41 is greater than 2.326. Here we reject H0. If the test value lies here, always reject H0. If the test value lies here, then accept H0. So reject H0. That is sufficient evidence that mu has increased or higher buildings in the city. So this is the way to write the conclusion. Here you need to write higher buildings on average. Must mention on average because mean means average. Next question. This question is from specimen 20, paper 6, question 7. The mean weight of bags of carrots is mu kilograms. An inspector wishes to test whether mu is 2.0. This means whether mu is 2.0 or not. So this is H1 and this is H0. And this is a two-tail test. He weights a random sample of 200 bags and he got these results. So here we need to find mu cap and sigma cap square as well. 10% significance. So number one, we need to find mu cap, sample mean, sigma x over n, 430 over 200. So 43 upon 2, which is 2.1 2.15. Sigma cap square 200 upon 199 1290 upon 200. You have done this in sampling. 2.15 whole square. And the answer of this is 731 over 398. Now we need Z test. Since population is unknown and sample size is large, as population is unknown and NS is 200, that is large, so this is the application of CLT, central limit theorem. So according to CLT, X bar is approximately normal. One minute, let me add one page. Okay, so X bar is normal, approximately normal, with mean 2.0. This is the mean 2.0. First write H naught, which is mu 2.0, and we write this value here. Remember, this is the value of H naught. Sigma cap square is 731 over 398 and NS is 200. So this is the distribution of X bar, and H1 is mu is not equal to 2.0. Now we need Z test. This is the formula of Z test. X bar minus mu over square root of this quantity. Sigma cap square over NS. So by substituting the values of all into this formula, we have X bar is 2.15, mu is 2.0, and square root of this quantity, 731 over 398 times 200. When we will solve this, we'll get this value, 1.565. This is Z test. Now we need to compare this with Z critical. The significance level is 10%, which is divided into equal parts because it's a two-tail test. 5% here, 5% here. And this value is 1.645. This is minus 1.645. Since we are getting positive value, so we will compare this value with this value. So by comparing these two values, or you can say Z test is less than Z critical, that is 1.565 is less than 1.645. So accept H naught because your value is here. This is in accepted region. This is not in critical region. So accept H naught, that is insufficient evidence to say that mu has changed. there is no evidence to say that mu has changed. This is the way to solve questions of these types, continuous distribution. First we got x bar, then we got sigma cap square, and then according to CLT we wrote the distribution of x bar, then we wrote h0 h1, then we got z test with the help of this formula, and then we compared this z test with the critical value. This value lies here. It's not in critical region, it's in accepted region. Here we accept h0 and here we reject h0. We reject h0 here and here. Since the value does not lie in critical region, so we accepted h0 and we concluded that insufficient evidence to say that mu has changed. Hope this lecture will help you to understand the questions of continuous distribution. Good luck and Allah Hafiz.